Hey everybody, today we're going to talk about independent and dependent events. So, compound events can be either independent or dependent. Events that are independent, they're independent events if the occurrence of one event does not affect the likelihood of the other event. Okay? So sometimes you have a situation where when you make a choice, it affects what comes in the other one. For example, let's say I had a bag of marbles and it had 10 red marbles in it and it had 2 blue marbles in it. And I want to know what's the probability of me reaching in and grabbing a red one and then reaching in and grabbing a blue one without putting the red one back. Okay, so it would be 1 in 12, or I'm sorry, it would be 10 and 12 to pick the red one. But then to pick the blue one, it would now be 2 out of 11 because when I removed the red one and I didn't put it back, it affects whether it affects the probability of getting the blue one. Now, if I had a situation where I had like a spinner and a dice, and I spun the spinner and then I rolled the dice, those are independent events. One of them does not affect the other one. Okay? So you'll see how we do some of these as we go through here. So the probability of independent events, the probability of 2 or more independent events is the product of the probabilities of the events. So the probability of A and B is the probability of A times the probability of B. The probability of A and B and C is the probability of A times the probability of B times the probability of C. Okay. So, for example, you spin the spinner and flip the coin. What is the probability of spinning a prime number and then flipping tails? Okay, so the first thing I got to do is I got to figure out, if I look at my spinner, I got 5 spaces. How many of them are prime? Now be careful. 2 is prime, 3 is prime, 5 is prime. A lot of people think 1 is prime, 1 is not a prime number. So I have a 3 in 5 chance of getting a prime number. Now, what's the probability of flipping tails? Well, I've got a heads and a tails, so I have a probability of 1 in 2 of flipping tails. So the probability of spinning a prime number and flipping a tails is going to be 3/5 times 1/2, or 3 in 10. Okay, that's 30%. If I want to write it as a percent, it's 30%. Okay, what's the probability of spinning a multiple of 2 and then flipping heads? Okay, so a multiple of 2. How many multiples of 2 are there? Well, there's this one, 2, and there's this one, 4. So there's a probability of 2 out of 5 of getting a multiple of 2. And then flipping heads, that's again 1 out of 2, because I've got heads or tails. So then the probability would be 2 out of 10, which would reduce to 1 in 5, or 20%. Okay. So there we go. Now, dependent events. So they're dependent if the occurrence of one event does affect the likelihood of the other event occurring. So the probability of 2 dependent events, A and B, is the probability of A times the probability of B after A occurs. So, people are randomly chosen to be game show contestants from an audience of 100 people. You are with 5 of your relatives and 6 friends. Okay? What is the probability that one of your relatives is chosen first and then one of your friends is chosen second? Okay, so there are 5 of your relatives out of 100 people. So 5 out of 100 is the probability that one of your relatives is picked. Okay, now the next is the probability of one of your friends being chosen. You have 6 friends, okay? But now there's only 99 people because one of them has been chosen already. So this will end up being 30 out of 9,900, which that'll reduce. Let's see, we can slash a 0 off there, and then 3 will go in there once, and 3 will go in there 330 times. So the probability is 1 in 330. And if we convert that to a percent, that's going to be about 0.003 or 0.3%. So not very likely. Okay. So there you go. You have a bag of marbles. There are 5 red marbles, 3 blue marbles, and 4 green marbles. What is the probability of reaching in the bag and pulling out a red marble, then pulling out a green marble, then pulling out a blue marble if you do not replace the marbles after you remove them? Okay, so the probability of getting a red one, there's a total of 12 marbles, and there's 5 red ones, so that would be 5 out of 12. Now remember, you removed one of the marbles, so we're going to pull out the green one next. Okay, so there's 4 green marbles, but there's only 11 marbles left to choose from. Now we're going to pull out a blue marble. There's 3 blue marbles, but there's only 10 marbles left in the bag. So there's my probability. So we'll go ahead and calculate that. That's going to be 5 times 4 is 20, times 3 is 60. And the bottom, that's 12 times 11 is 132, times 10 is 1,320. Okay, and we can simplify that a little bit. Divide by 10. I don't know, will 6 go into 132? Yes, 22 times. So this is going to reduce to 1 in 22. If I wanted a percentage, 1 divided by 22, that would be about 0.045, which would be 4.54%. Okay. What fun, huh? All right, a student randomly guesses the answer for each of the multiple choice questions. What is the probability of answering all 3 questions correctly? Okay, so I've got 5 choices in the first question. So the probability of choosing randomly and getting it would be 1 in 5. Okay, now the second question also has 5 choices. They are not dependent on these. So again, I have a 1 in 5 chance of picking it at random. And the same goes for the third question. It's also 1 in 5. So 1 times 1 times 1 is 1. This is 125. So you got a 1 in 125 chance. That's 0.008 or 0.8%. So I would not recommend randomly choosing answers on a multiple choice test, especially if it had 5 choices. Better to study. Okay. We're going to do 1 through 29 odd. And I will see you guys in class. Have a good evening.